2022 Grade 8 Gauss Math Contest, questions 21 through 25. The positive factors of 6 are 1, 2, 3, and 6. There are two perfect squares, less than 100, that have exactly 5 positive factors. What is the sum of these two perfect squares? So we can do this manually, or I can show you. It's not a trick, it's just a system. Let's say you have a number and it's broken up into its prime factors, where a is a prime number and m is an exponent. The number of factors would be calculated as simply m plus 1. Okay, that's an easy way of doing it. So for example, if n was equal to 2 to the power of 3, the number of factors would be 3 plus 1, which is 4. Now what if you have two prime numbers? It's a to the power of m, b to the power of n. Well, you do m plus 1 times n plus 1. So for example, if n was equal to 2 to the power of 2 times 3 to the power of 2, the number of factors would be 2 plus 1 times 2 plus 1, which in this case is 3 times 3, which is 9. Got it? So that's a quick way of doing it, and it's very helpful. It helps you save time instead of doing this manually. And on math contests, you always want to save time. So they want you to look at the perfect squares that are less than 100. So what do we have? 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, and I believe 9 squared is the last one, because 10 squared would be 100, and therefore that is not less than 100, because they want it less than 100. Okay, so I'm going to break them up into this form, prime form, because that's the only way we can use this system, right? Okay, well, 1 squared is already in that. Well, 1's not a prime. I mean, so I don't even know what to do there. This is not. So we have to break it up into 2 to the power of 4, right? This is not. So this is going to be 2 to the power of 2, 3 to the power of 2. This is already in prime. This is not. So it's going to be 2 to the power of 6, I believe. And this is also not. It's going to be 3 to the power of 4. Okay, so now we have to figure out which ones have 5 positive. This one doesn't have 5. This one has, using this system here, 3 factors, right? Yeah, 3 factors. This one will have 3. This one will have 5. This one will have 3. This one will have 2 plus 1 times 2 plus 1. So 3 times 3, 9. This one will have 3, 7, and 5. So which ones have 5? This one, and those numbers are these guys. 4 to the power of 2 is 16. 9 to the power of 2 is 81. And they want you to add those two guys up, and that would make 97. Therefore, E is the answer to this question. Number 22. The list PQR, STUV, each letter represents a positive integer. The sum of the values of each group of the 3 consecutive letters in the list is 35. Q plus U is 15. Then what is the sum of all the letters? Okay. So P plus Q plus R plus S plus T plus U plus V. Okay, so how do we approach this here? Interesting. Oh boy. Okay, well, any 3 letters that are consecutive will add up to 35. So that's going to be 35, right? Yeah. And then Q plus U, they told me that that's 15. So those two are 15. So I can reduce this whole thing to just P plus V, right? This guy and this guy, which I don't know. And then the 15 for the Q plus U, and then the 35 for the 3 guys in the middle. So that basically becomes P plus V plus 50. Okay, great. Where do I go from here? All right, let's see here. Well, I think we can just utilize what we just found out instead of trying to do something new. So P plus V plus 50. So that means that this whole thing, therefore, is 50, right? Because the whole thing is P plus V plus 50. So therefore, the ones in the middle must add up to 50. And again, utilizing the same fact that 3 consecutive letters always add up to 35, then that means that these 3 letters would add up to 35, and since all of those add up to 50, Q plus R must be 15, right? Does that make sense? Hope so. And in a very similar way, these 3 letters add up to 35, and since all of those 5 add up to 50, then that means that T plus U, just those 2 would be 15. Yeah. So we just got to manipulate this and then add all these guys up, and you get Q plus R plus T plus U is 30. But Q plus U we have right up there. So that's R plus T plus 15 is 30. And therefore R plus T is 15. Oh, okay, got it. R plus T is 15. So if you look at these 3 guys in the middle, we know that R plus S plus T is 35, right? Because there's 3 consecutive. R plus T is 15. So 15 plus S is 35. And therefore S is equal to 20. Aha, got it. All right, so I understood now. I was a little confused. So if S is 20, well, these 3, they're 35. These 3 are 35. And then we add that to the S, which is 20. And there you go. So the entire lot would be 35 plus 20 plus 35. So that's 90. So I guess the key to this was arriving at this. 90 is the answer, so number 22, that would be D. The net shown is folded to form a cube. An ant walks from face to face on the cube, visiting each face exactly once. For example, A, B, C, F, E, D, A, B, C, E, F, D are 2 possible orders of faces the ant visits. If the ant starts at A, how many possible orders are there? Okay. Well, we need to first, let's make a diagram that is a little bit obvious. What I mean by that is that will help us because I want to fold it. If you fold it up into a cube, I think it makes it a little bit easier to understand. Okay, so now let's label this B at the bottom. F is the front face, which in a way is good because B bottom, F front. And then A goes in the back there, and then C is out here on the side, D is on the side, and the top is E. And if you draw it like that, I think it makes it a little bit easier to create. Okay, so we've got to create a system that somehow creates pathways for the ant. And we have been told that we start with A. Okay, so if we start with A, we can go to any adjacent face. The only face that we can't go to is a face that is opposite. So that's the key to this question, is that you can't go to the opposite. So for example, A is here, right? Well, you can see on the diagram. So which one can you not go to? You cannot go to F, right, from A, because the ant can't hop over. It has to go to adjacent faces. So the faces that you can go to from A are B, C, D, and E. Got it? So that's basically the process. And the good news is, this is very time consuming, but the good news is that, well, what is the good news? The good news is that you can see that if you figure it out for just one of these guys, all the other 3 have the same sort of properties. So I'm just going to figure it out for B, like A to B. You know what I mean? You go from A to B and then you continue. And then the number of cases, that would be the same for C, D, and E. And you'll be able to see that. So here we go. From B, where can I go? Well, from B, I can't go to A because A is already done. Obviously, I can't go to B. And I can't go to the opposite, which is E. So I can only go to C, D, and F. Right? Similarly with C, I can only go to B, E, and F. With D, I can only go to B, E, and F. And for E, I can only go to C, D, and F. Okay? I just wanted to write those out I'm just going to concentrate on this pathway here. The A to B and then the B to these guys. But I just wanted to write those out. Okay, now is when we start to just concentrate on these guys. Same kind of principle. From C, where can I go? Well, I can't go to A, B, or C. Those are already done. And I can't go to the opposite, which is D. So the only choices left are E and F. Similarly for D, the only choices are E and F. And for F, the only choices are C and D. Right? Because I can't go to A, B, or F. Those are already done. And from F, I cannot go to A because that's the opposite. I can only go to C and D. All right, we're moving right along here. From E, where can I go? Well, there's only one choice at this point. There's D. That's it. Right? Because A, B, and C are already done. Can't go there. From E, I can't go to I can only go to D. Now you might say, well, why can't you go to, let's see here, F? From D you can go to F, right? Yeah, you can. Okay. Sorry about that. You can go to F. All right. And then from F, I've got only two choices. I can only go to E or D. From this guy, I can go only F or C. From F, it looks like I can only go to E or C. For C, I can only go to E. And from D, I can only go to E. Yeah, those guys only provide one choice. Because from C, A, B, F, those are done. So obviously those. C is the next one. So I can only have E or D, but I can't go to D because if I go from C to D, that D is the opposite, right? Yeah. Okay. And then let's just complete this now. Final step. Well, there's only one letter left, so the final step is fairly easy. Whatever letter is left is the one that you go to. So that's what I'm putting in here. Let's see here. That one, the C. That one is F. This one is C. This one is E. This one is D, and this one is C. Okay. So how many did we get here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we got 10. So that basically was the story for this guy. 10 possible. And you will see that when you do it for C, D, and E, it'll be pretty much the same thing. 10 here, 10 here, and 10 here. And I'll let you guys do that. You certainly don't want to hear me go through that again. So the total is 40. And therefore, number 23, the answer is E. The number 385 is an example of a 3-digit number for which one of the digits is the sum of the other 2 digits. How many numbers between 100 and 999 have this property? Okay, so N is between 101 and 998 inclusive, right? And the number, let's just say the number is of the form ABC. These are the 3 digits. So, and let's say A is the largest. So that would mean B plus C is equal to A. But A could also be in the middle, or A could be the last one. So I'm just trying to get an idea of how to approach this. And I think there's going to be different scenarios. The first scenario is any number that has a 0 in it. That is what we have to figure out first, because the 0 is a little tricky, because if you have a number like A, B, C, A cannot be 0. Because if it was a 0, it would become a 2-digit number, and they only want 3-digit numbers. So only the B or the C can be zeros. So let's make a little table, A, B, and C, and let's see what we get. Okay, so let's start with 1. That's the smallest number A could be. If that's the case, then we would have 0, 1, and 1, 0, right? Because in this case, B plus C would equal A. Yeah. Okay, keep going like that. 2, it would be 0, 2, or 0, 2, like that. And remember, I'm only putting in zeros. And similarly, dot, 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 all the way down to a 9, it would be 0, 9, and 9, 0, like that. So for each number, for A, you get 2. So we have 9 times 2. We have 18 of these guys. Okay, so hopefully that wasn't too bad. So now let's look at the second scenario. And the second scenario is if you have two same digits. So I'll give you an example. Again, we'll make a little table here, A, B, C. And the smallest number, of course, is 1. So if you have 1, 1 like that, this has to be a 2 because B plus C have to be equal to A. So that's about as small as we can get. But this can be rearranged 2, 1, 1 like that, or 1, 1, 2. So you see what I mean? A is not necessarily the largest now. But the property that one of the digits is the sum of the other two digits is maintained. Okay, let's keep going. Let's see how much more we can do. Let's say we have 2 this time for values of B and C. Well, that would be 4, but then we can also rearrange it like this. Got it? Okay, and I think we can keep going. How about 3? That would be 6, but then the 6 can be rearranged. And then 4, that would mean 8, and the 8 can be rearranged. And I think that's it. Because if you put 5, then you get 10, but 10 is not a digit, right? So how many did I get here? How many did I get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I got 12 here. Okay, good. Moving right along. So we got 18 and 12. And then the final scenario is there's no 0, and all 3 digits are different. Okay, so let's make a table again, A, B, and C, and let's see what we get. So if all 3 are different, B and C, the smallest value, we can use 1. We can't use 1 because remember, all 3 are different, so 2 is the only one I can use. Well, the smallest one I can use, and therefore this is going to be 3. Got it? See what I mean? Okay, so let's go for A equals 4. That would give me 3 and 1. And I think that's it. And then the permutations I'll talk about a little bit later, but let me just get through this right now. 5 would be 4 and 1, but you can also have 5 with 3 and 2. And it kind of goes on from there, right? You guys get the point. 6 would be 5 and 1. 6 could be 4 and 2. You can't put 3 and 3 because remember, all 3 are the different. 7 would be 6 and 1. 7 would be 5 and 2. And 7 could also give 4 and 3. Let's see here. I think 8 would give me 7, 1. 8 would give me 6, 2, and also 5 and 3. And I think with 9, I can get 8, 1, 7, 2, 6, 3, and one final one, 5, 4. Now, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 of these. But here's the thing. Each of these has 6 permutations, right? So for example, the first one, 3, 2, 1, but you can also have 3, 1, 2, 2, 3, 1, 2, 1, 3, 1, 2, 3, and 1, 3, 2. And similarly, for each of these, you can have 6 permutations. So 16 you have to multiply by 6, and that gives me 96. So there we go. This 96 plus this 12 plus that 18, and that is 126 if you add those up, and that would be choice B for number 24. Student A, Student B, and Student C have been hired to help scientists develop a new flavor of juice. There are 4,200 samples to test. Each sample contains either blueberry or does not. Each student is asked to taste each sample and report whether or not they think it contains blueberry. Student A reports correctly on exactly 90% of the samples containing blueberry and reports correctly on exactly 88% of the samples that do not contain blueberry. The results for all 3 students are shown below. Student B reports 315 more samples as containing blueberry than student A. For some positive integer m, the total number of samples that the 3 students report as containing blueberry is equal to a multiple of 5 between 8,000 and 9,000. The sum of all such values of m is. Well, the first thing I want to do is explain this question, and I will do so with an example. So they tell me that there's 4,200 samples, right? Now, I don't know how many contain blueberry and how many don't, so I'm just going to make a guess. Let's say 3,000 contain blueberry, and therefore the remaining 1,200 do not contain blueberry. Okay, it's just an example to explain what this question is talking about. Okay, so then what they do is they make this little table, A, B, and C, right? And they say that they correctly guessed which ones contain blueberry and which ones did not contain blueberry. Okay, so let's make up some numbers to talk about this, because if I use just letters like N or M, it's going to be very abstract and you won't understand it. Let's say that A, after testing the 3,000, he or she, could be female, male, I don't know, thinks that 2,700 of them contain blueberry. Okay? Now, that means that of the 3,000, he got 2,700 correct, which is, as a percentage, 2,700 divided by 3,000, which is 90%. So he got 90% correct with regard to which contain blueberry. And that means the remaining 300, he got incorrect. Like, he tasted them and he thought, well, I don't think this contains blueberry. Similarly, he tastes the 1,200, and let's say he decides, I'm trying to match up the percentages, so that's why I'm going to choose this 88%, which is pretty much given in the question. That's what I'm trying to do. That would mean 1,056 he matches, meaning he tastes the 1,200 and he says 1,056 I believe do not contain blueberry, and therefore he's correct because those guys don't contain blueberry. So that is indeed the 88%. And then the remaining 144 he was incorrect, meaning he tasted them, and even though they don't contain blueberry, he thought that they do contain blueberry, so he was incorrect about those. Okay, so that's how the numbers, you see there was numbers up here, see 90 and 88, see that? So that's why I purposely chose these numbers here to make the percentages the same. Okay, let's talk about B. B is the same story. The percentages here I believe were 98 according to the table and 86, right? So this matches up those. To get 98, that would mean 2940, because 2940 over 3,000 is equal to 98%. Okay, so that means that he or she tried the 3,000 samples that contain blueberry, and she correctly identified 2,940 of them to contain blueberry. But 60 of them, she said, I don't think they contain blueberry. So she was wrong on those 60. Now, then she tried these guys, the 1,200 that do not contain blueberry, and she correctly identified that 1,032 do not contain blueberry. And the reason I came up with that number is because 1,032 over 1,200 is 86%. And that means the remaining 168, she was incorrect. She tasted them, and she said they do contain blueberry, but she was wrong because they don't contain blueberry. Got it? Okay. Now they talk about this 315. Student B reports 315 more samples as containing blueberry than student A. So what does that mean? That means, which numbers do we have to look at to make that comparison? We have to look at this one and this one. And then compare it to this one and this one. Let's read that again. Student B reports 315 more samples as containing blueberry than student A. What I circled are the samples that she tested and said these contain blueberry, regardless of whether she's correct or not. So let's see if our math works out. It's not going to work out, but let's just see, because this is just an example. 2940 plus 168 is 3108. Got it? And then the other guy, 2700 plus 144, that is 2844. Yeah. Now let's compare these. 3108 minus 2844 is 264. Okay, not a problem. I was just giving an example. They want a scenario where that number is 315. Got it? So this number must be 315. Okay. So at this point, I will start using N's and M's and all that stuff, because if I did it immediately, it would be way too abstract, and I don't think you would have understood anything I was doing. So now that you have hopefully understood how this process works, let's now do this again, but this time we'll introduce letters, because we don't know what is the number of positive blueberry and negative blueberry. Like I had chosen 3,000 and 1,200. We have to actually figure out what is the actual number. So we can do that now. Okay, here we go. So again, very similarly, we have 4,200. That much we know. That's the total sample. And we'll call the number that contained blueberry N. So N that are positive for blueberry. And therefore 4,200 minus N are the ones that are negative for blueberry. Got it? Okay, so now we start filling out this table. He's got to achieve 90%, right? So that means 0.9 N. And that's got to be his percentage. And then 0.1 N is the percentage that he got wrong. I put that in brackets. In a similar way, we have to get 88%, right, for this next part of the table. So that's 0.88, but not times N, this guy. 4,200 minus N. Right? Hopefully that's right. And then the complement is what I'll put in brackets, which is the other part that he got incorrect. So that's the part he got incorrect. So I'm pretty much doing the same thing I did up here. The only thing I'm using N's this time to identify the unknown. I could have used X, any letter. X, any letter is sufficient. Same thing with B. Her is 98%. So that means 0.98 N. And then, of course, the complement is what she got wrong, which would be 0.2 N. Got it? And then 86% is that part of the diagram or box. So it'd be 0.86, but not N. It's multiplying by 4,200 minus N. And then the complement is 0.14 times 4,200 minus N. Okay. And the C's, we'll talk about that later. Let's just get through this now. Okay. Now, very similarly to before, how did I figure out this comparison? I circled which guys? I had to circle this guy, right? I had to circle this one. And then on this side for A, I had to circle that and this one to get the comparison. Correct? Hopefully you agree with me. So in a very similar way, I will do that. So it's basically this 0.98 N plus that 0.14 times 4,200 minus N, this whole thing, which I think was represented by those two numbers. And then I've got to subtract from it these guys, which in our case with these N's would be 0.9n plus 0.12 times 4200 minus n. Okay? And this is what has to equal 315. So this is what we want to equal 315. Okay, so this is not too bad. So let's try to solve this. 315. Okay, 0.98n plus 0.14 times 4,200 is 588. And then we have this minus 0.14n minus 0.9n. 0.12 times 4,200, 504, so minus 504. And then 0.12, so it'd be plus 0.12n when you take it out of the brackets. Okay, hopefully there's no mistakes there. And then this guy, and this guy combined to give you, and this guy also, so 0.06n. And then we have some numbers, right? Plus 84. And then this one becomes 231, 0.06n. Divide through by 0.06, and that would give you 3850. There you go. Okay, so all that hard work to come up with the actual number. I had guessed it to be what? I had guessed 3,000. Not a problem. I mean, it doesn't really matter what I guessed. 3,850 is the actual. Okay. All right, so hopefully that is what the first part of the question in this solution. Okay, now we can finally go to C here. And they don't give you any numbers. They just give you 2m%. 2m%. And then here they give you 4m%. Okay, not a problem. I know that my total number is 3850. Got it? So that is going to be very, very helpful for us because we will be able to figure this out now. So let's fill it in. Let's fill in all the numbers. So with this number in mind, 0.9n, since n is 3850, that number is going to be 3465. Okay, I'm using n equal to 3850, which is what we figured out. 0.1n, that's going to be 385. Got it. This 0.98n is 3773. 0.2n is 77. And then these numbers are 308 and 42. And this guy over here is 301 and 49. And this one, well, we don't know what m is, so unfortunately we've got to do a little math here. It's going to be 2m over 100 times that 3850. Okay, and this one is going to be 1 minus 4m over 100 times that 350. So I will need to explain the C a little bit more. So let me explain it a little bit better. A little bit. I already explained it well, but a little bit longer. So very similarly, if you have 2m percentage, it'll be 2m over 100 times n, and n is 3850. Okay. Now the complement would be 1 minus 2m over 100 times 3850. That section of the table. Now this guy is 4m over 100 times, what do we multiply it by? 4200, remember? Where was it? 4200 minus n, right? Just like we did up there. Where is it? Oh, right here, yeah. Right here, 4200 minus n. So that's what I'm going to do. 4200, well, n is 3850, that we figured out. So that's 350. So this is going to be 4m over 100 times 350. And then the complement is 1 minus 4m over 100 times 350. Okay? And to figure out how many tasted and said that it has blueberry, if you go back to the question, right? How many samples contain blueberry? Remember, we had to circle this guy and this guy. So same thing here. We have to circle this guy and this guy, right? Because those are the ones that C would have tasted and said they contain blueberry, regardless of whether he's correct or incorrect. Okay, now we get to the final step. All right, great, wonderful. The final step is adding up all these guys. This one, this one, this one, this one, this one, and that one. That represents the total. The total. The total number of samples that the 3 students report as containing blueberry. Okay? That is the total. So let's do that. So it's going to be, we have good news is we have numbers for these guys. We have 3, 4, 6, 5 plus 42 plus 3, 7, 7, 3 plus 49. And then this one we don't have numbers, but we can get numbers. If you multiply 2 by 3850 and divide by 100, you get 77, but there's an m in there. And then if you, this guy here, well, the 1 is going to give you a 350, but then if you multiply 4 times 350 and divide by 100, you're going to get minus 14 m. And now that is equal to a multiple of 5 between 8,000 and 9,000. Okay, so it's a multiple of 5, so it'll be 5k, where 5k is between 9,000 and 8,000. Got it? All right, so we are in the home stretch here of this question, and here we go. So add these guys up, and you get 7679 plus 63m is equal to 5k. So take out your calculator and let's just add 7679 to multiples of 63 until we get above 8,000. And the first guy above 8,000 is 8057. And that we have to see, is it a multiple of 5? And if so, for what value of m? Okay, shouldn't be too hard. Well, that's not a multiple of 5, right? Because multiple of 5s end in either 0 or 5. Okay, keep going. Keep adding 63. 8120. 8183. 8246. 8309. 8372. Let's see here. Keep going here. 8435. 8498. 8561. 8624. 86. 87. 8750. 8813. 8876 and 8939. Okay, after that, we don't go because it would be beyond our limit. Okay, so how many of these are multiples of 5? This one is no, 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 yes, no, 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 yes, and no, no, and no. Okay, so for what value of m did we get this? Well, you can just sub it into that. You can sub 8120 there and solve for m. And when you do, you get 7. Similarly here, it's 12, and here it is 17. And they want you to figure out the sum of those m values. So it would be 7 plus 12 plus 17, which is 36. And that is the answer to this question, B, 36. So let's see, go back. 36 is B, yeah. So if you are in grade 8 and you can solve this question, that is truly outstanding. I mean, I have a university degree in math, and I was able to do it. But if you're in grade 8, which is age 13, 14, and you can do this question, you have my highest compliments.